working on problem 6b. We've taken and made these into molarities, the initial and the equivalent. We've now put up the change. So what I can do right now is this part right here lets me be able to solve for x. So the difference between 0.6 and 0.2 is what? 0.4. So I know 0.4 has to equal 2x. So what's x? X equals 0.2. Okay, so up here I can really quickly say, oh, instead of x here I can put 0.2. And instead of x here I can put what? 0.6. Okay, so I can put those instead. That means my equilibrium is going to be 0.2 molar and 0.6 molar. Everybody okay with that? Okay. Where did I lose you? Because when they put it in, there's nothing here on the I for N2 and H2 because they just said I placed 6 moles of NH3 in a 10-liter container. So now it's got to come to equilibrium. I had nothing of this over here. Okay, so then we go through the change, and the change comes from the coefficients here. Okay, and since we knew we had NH3 but we didn't have H2 and we didn't have N2, we're going to subtract from the NH3 and move some of them over to this side. Okay, so that's where I got that. To write our KEQ, we're going to just start and write the KEQ for like normal. So products, NH3 to their coefficients as exponent, divided by reactants to their coefficients, which is 1 here, as exponents. Then I plug in what I just found at E, because that's at equilibrium. So I'm going to have 0.2 squared divided by 0.2 times 0.6 cubed. Now make sure that this is all together on the bottom, because if you don't put a parenthesis around it all the way, or put it in first and do 1 over x, so it goes on the bottom, all of it, you're going to end up timesing by this on the top. Okay? So go ahead and plug that through. What do we get? That's what a lot of the kids were getting. I want to grab a calculator, make sure we're putting it in right, or make sure I put it in right. 0.2 times 0.6 cubed. I'm going to put that on the bottom, times 0.2 squared, 0.93. So I did something wrong when I did it. Okay.
And that's the key to that for you.
Mm-hmm. That's the answer that you need.
Do you want us to still do the...
Still do the what?
I have like written down here like reverse non-spontaneous.
Yes, that would be awesome. So this is reverse. It's probably non-spontaneous. Okay. 3, 0.93. Okay. Any other questions? Number 7. I knew that was coming. It does tell you the KEQ. So the first thing I gave you was KEQ equals 15, right? Okay. Just put it to the side for a minute and then go to your equation, which is 2SO2 plus, and this is a gas, plus O2 as a gas goes to 2SO3 as a gas. Sorry, that S is a little funky. Okay, then it is said a certain amount of SO3 was placed in a 2-liter vessel. So I have a 2-liter vessel, but I don't know how much was placed in there. Okay, but this is like the one we just did. So on ice, I had 0 of this to start with and 0 of this. But I don't know how much SO3 was added in. Then it says at equilibrium, the vessel contained 0.3 moles, so we're going to come over here, 0.35 moles of O2. Well, before I can put it in the ice table, it's got to be in molarity. So I'm going to divide that by 2.0 liters, and I get 0.1 something. 175, okay. Molar. So over here under oxygen, here I can put 0.175 molar. Because it said at equilibrium, the vessel contained 0.35 moles of O2, and it was in 2 liters, so that's why I divided by 2. Okay, so now I need to do the change, because the change I can always do by looking at the equation. I had SO3, so I'm going to take away from SO3 and throw it on the other side. So over here, I'm going to have a minus 2x. Remember that the coefficient's where I got the 2. Then I'm going to have a plus x and a plus 2x. Everybody okay?
So we know that x equals 0.175?
Right. So we know x equals 0.175. So I didn't even have to do any calculations. So I know that SO2 is going to be 2 times that number. Well, I had 2 times that number right here, 0.35. So all I have to do is go say this is 0.35 molar. I still don't know what SO3 is. So let's write the KEQ. KEQ for this equation is going to be products SO3 to the squared power divided by SO2 squared times O2. Everybody okay with writing the KEQ?
Yes, KEQ doesn't matter what goes first.
Mm-mm. Now, I have everything but SO3, right? So I can plug everything in. So 15 is equal to, I'm going to call SO3 x, because then I don't have to rewrite it over and over again. So x squared on the top divided by SO2, 0.35 squared times by O2, 0.175. And now I just solve for x. Okay, solve for x, get a number. That's not our final answer, though, because it asks how much was put into the box or into the container. So when you get an x, let me know. Don't forget to square root it. 0.567?
Yes.
6.7, so we'll go 0.57 molar. That's going to go here. Now, how do I find what it was initially? I add the 2x back onto it, so I'm going to take 0.57 plus 2 times 0.175, and I get what for the answer? 1.83, so 1.8. And that is the answer they want. Oh, no, yeah, that's not the final answer because they want moles. So this is molarity. So you, one more time. Okay, so, sorry. 0.92. Okay, so that was molarity, and then you times it by the 2 liters, and that will give you the 1.8 moles. So we'll get rid of the M up here. Okay, 1.8. We got 2 significant figures.
So that is the answer.
Uh-huh. Okay. So what we'll do with that, since we basically did the 2 that I was going to check because all the others are real fast and easy to check, we'll just hand that one in, okay? Second one, let's look at what we're doing today. Today we've got 2 worksheets that you picked up at the back. The first one, the chapter 18 KQ equilibrium, is what we just did with his last 2. More practice. Okay, with ice. It's 6 and 7. More practice with ice. I gave you a lot more room. Now, don't freak out, because some of them are this one. Okay, some of them are very simple, and you don't have to go through ice. So read the question, okay? Some of them are just asking what the equilibrium is. So watch that. The other one is KSP. Remember I told you there's tons of different Ks, but you always set them up the same. Products over reactants, put them to their coefficient. KSP is K of solubility. So it has to do with our solubility rules. Everything has some solubilities, okay? So if we look at this first one, that was as an example, it asks for to compare the KSP of Ag to CO3. So what it's basically saying is I started with this as a solid, and I'm going to go to 2 Ag plus AQ plus CO3 2 minus AQ. So I'd write the KSP for this. What do we know about KSP? What do we drop out of KSP? Solids and liquids. So when I write the KSP for this, KSP is just Ag plus squared CO3 2 minus. Done. Got it, Parker? Okay. So this is an example. So then all I have to do is plug in the numbers. So for KSP, it's equal to 1.0 times 10 to the negative 6 squared times 2.5 times 10 to negative 5. I would times that out, and you get 2.5 times 10 to the negative 17. Okay, I gave you what the KSP is. The KSP is like saying this is what a saturated solution can hold. Okay, so if this number right here, which we actually don't call KSP, we call it Q if it's not at equilibrium. So if it's not at equilibrium, we call it Q. So this is Q. Okay, and I compare Q to the KSP, which they gave me, which was 8.54 or 45 times 10 to the minus 12. Which number is bigger? This one is bigger than that, right? So because this is bigger than that, this is a non-saturated. Oh, geez. Saturated solution. Okay? So in other words, I haven't dissolved as much salt as I possibly could. If it was equal, then I would have a saturated solution. If it was bigger than, I actually would have a precipitate because I couldn't dissolve anymore at that temperature. So I'd have a precipitate. So what I want you to do on this KSP problems is tell me what type of solution I finally have. Okay, but show me the work. Show me what this is right here. Set this up right here so I can see that you understand what's going on. Remember that if the coefficient here is smaller, or sorry, the exponent is smaller, it's actually a bigger number. A lot of kids have problems with that. Now, there is one that your calculators will go is equal to 0. And you're going, wait a minute, I just put numbers in and I times them together. How can that be equal to 0?
So darn small.
Because it's so small. So if it says 0, which one's smaller, 0 or a number? 0. Okay, so 0 is going to be the smaller number. Okay, and I had a lot of kids out, but that doesn't make sense. Well, nothing compared to something, nothing smaller. Right? Okay, so today working on KSP, working on equilibrium constants, and we'll correct them next time. No lecture tonight. Okay? All right.